everyone. I'm going to talk you through some of the work here in Section 3. This part of the assignment is when we're actually getting into the chemistry of it. So yes, this unit is called biochemistry because it's the chemistry about biology. If you were in chemistry last year, you've seen some pictures like this. So you can help explain that to your classmates who may be taking biology without chemistry before. Essentially what's happening here is I'm looking at this molecule right here, carbon dioxide, and the word dioxide actually means two oxides, so there's that two, carbon dioxide. Here we have our friend water. So both of these things come together in the leaf of a plant, carbon dioxide from the air, water through the roots. You also need some energy in the form of UV light coming from the sun. And what plants do is they take all of that and they make this big molecule here. This says that it has 6 carbons, 12 hydrogens, and 6 oxygens. Those little numbers at the bottom tell me how many of each element I have. This is glucose. It's a simple sugar. And as a byproduct, they make oxygen, which is helpful for us because we want to breathe. What we're doing here is we're trying to take a look at, we're trying to account for all the molecules, and how they get broken apart to make our new molecules. In chemistry, we did talk about this, and that is that each of the molecules needs to get broken apart. Every carbon that starts on the left ends up on the right, every oxygen, they all work out, they balance that way. But here we're going to talk a little bit about the energy that it takes. When you make a chemical reaction, you have to put energy in order to break all these things apart. So every single one of these lines here is a connection between atoms. It's a bond, and it takes energy to break it apart. So we put energy in. Then on the other side, once we start putting them back together, we get that energy back. So it's kind of like a bank investment. You put some money in, and then you get some money back. Sometimes it's more, sometimes it's less, and we'll find out how it works out. All right, so here's how this works. Every bond type has its own difficulty of how hard it is to pull apart. So this one with the double bond, this is 2 bonds connected between carbon and oxygen. These cost a lot to take apart. So all I need to know is, well, how many am I doing? So I can just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 of them. For every one of those, I need to put in 799 energy units. So if I multiply, I'm going to get a really big number here. I'll let you do that math. Here, every time I see oxygen connected to hydrogen, I'm going to count how many that is. And over here, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 again. So I'm going to multiply and get a number here. And then if I add these, I will find the total energy that it takes to break apart bond. On this side, I want to count how many I've made. So again, I'm going to look to see how many different kinds of bonds I have. So here in oxygen, I have a double bond between oxygen and oxygen. I know they look like weird faces. And I get this right here. So I'm going to count how many of those I have. And then the rest of these bonds are in this molecule here, which is going to take some time, but kind of look to see how things are connected. Here I see carbon connected to carbon. So that's going to be this category. Here I see carbon attached to oxygen. Carbon attached to oxygen. So that's going to be here. Here, carbon, oxygen. Anywhere I see O and H next to each other, I can think about that as O connected to H. Here I have O connected to H this way. Both ways it's the same bond, so it's the same energy. So anywhere I see this, I'm going to count that as H and O. You might be wondering what to do with this mess up here. Well, I tried to find some good diagrams, but this was the best one I could find. So I'm just going to redraw this up here. So this carbon is here. So this is this bond. And here, what this actually means is it's connected to H here, connected to H here, and then connected to OH here. So now I can see that I have more of those CH bonds to count, a carbon-oxygen bond to count, and an oxygen-hydrogen bond to count. All right, so go on a little treasure hunt. Count all the different kinds of bonds there are, how many of each kind there are, total energy, and you're going to get the total energy here to find out how much energy you get back. And then we're going to find out, do we get more energy back than we put in? Or does it come out even? Or do I get more back? Wait, I think I said both at the same time. That's okay. All right, have some fun with it.